context of where these tutorials fit into the grand scheme of things. So the intent, of course, so we have several participants online that I can see. And so I don't have the Mattermost up right now, but we do have Kalia who will be monitoring it. So as anybody that's online or in the room, if you have questions and you want to post them on there, of course, you can also stop. If you're in the room, you can easily stop and ask me. But if anybody's online, you can go ahead and just drop your questions there. And if you're not set up on Mattermost yet, which we'll have a little time built into the end. Yeah. If you see hands raised on Mattermost or comment, if you can try to answer them on Mattermost, that would be helpful. And I'll try to catch people on the Zoom because I think I can see it here. Okay. Yes, so if anybody's not set up on Mattermost yet, which we'll probably have a little time built in at the end to see if there's any other questions to get people caught up, then just feel free to post the questions into the chat, into the Zoom. I can see that right now. So I think everybody can see my screen, everybody can hear me. So I'm Holly, Zoomel Advanced. So I'll be giving basically this kind of general introduction to overview on basically, where the different software tutorials can be accessed, where they fit into the problems you might solve. And so we'll start kind of broadly, just referring back to our EIC software statement of principles, right? So there's several, if you haven't read them, I recommend you read them at some point, but of course, just for the general, for your general kind of understanding, the EIC software statement of principles contains many aspects, and that's a lot of these aspects user learning is trying to support, right? So in the first in the first bullet we talk about developing a diverse workforce, and so one of those aspects, of course, is providing the tools to you and training you and helping you to be able to be a collaborative member contributing to the software. Some of the other ones, that I'll mention specifically to this session, of course, so we're talking about it should be heterogeneous, right? So we want it to be able to run on as many systems as possible, and that, that way, again, it's sort of accessibility, right? That everybody can access this. A user-centered design. So that's a really big deal. And that's another reason why, you should be able to run EIC software where you work and how you work. And we also want to have sort of a modular development for you to be able to develop algorithms and contribute onto the software. So let's see, some of the other ones that I wanted to mention, in terms of reproducibility, right? So everything is, we want everything to be reproducible so that we're not in some instance where you're trying to, figure out what changed, 5 versions ago, and there's no way to track that, right? So we have a lot of different people working on a lot of different systems, a lot of different aspects of the software, and so it should be all reproducible and documented. We embrace the community, so that's kind of a big one, from my standpoint on user learning, is that we want to support you so that you can contribute to the software. This isn't a collaboration where we just have a bunch of computer scientists working somewhere else, developing all the framework. So that's why this should be really, we want to support all the scientists who contribute to the software. Okay, so I put the links, I tried to include all the links on all the slides as well. So if you want to go back through these slides later to take a look at some of the places that I point to, you can do that. Okay, and then I was just going to refer to kind of our general structure where we fall in some of the working groups that you might interface with, right? So, yeah, okay, I see the Mattermost invite. So we have, detector working groups, we have software working groups, we have physics working groups. And so one of the ones that I'm going to kind of just focus on, and I'll try to point to where these items fall throughout the tutorial because you'll interact with these different groups, but it's the software, working groups. So depending on what you're doing, you may need to, interact at some level with these groups, whether you're joining them or asking them for things. And so just kind of in a very general way, we can talk about like a real experiment, right? So real experiment, you have your physics interaction, your EA collision in this case, and you have this happening, you have your epic detector, so which has all of your front end electronics, all of your detectors, cables, everything that you can imagine kind of physically associated with this detector has an acceptance for measuring things. And then you can read out, so then you basically, you have these signals that get passed into your electronics and your data acquisition. So they get digitized in some way, and then they get read out in some stream form and saved to some sort of kind of like output file in a sense. Then from there, you can go to reconstruction. So if you're talking about, for example, like a calorimeter, okay, so you can think back, if you go back to this kind of detector concept, then you think of the calorimeter, you think of, this yield inside, it goes into maybe your photomultiplier tube or APD, whatever you have reading out the signal, converting the signal to electronic signal, being read out by some electronics in a crate somewhere. And then, but at some point you have, in your reconstruction, you kind of begin with, eventually you'll start with like a list of hits, right? So you'll generate like this list of hits, and then maybe you want to do some clustering, right? So then you'll take these lists of hits and you'll start to cluster things together and build things that look like the energy of the incident particle that kind of splashed across this detector, right? So that's where you do your reconstruction. You'll have your data production, so which basically kind of cooks everything. So if you were to reconstruct, for example, the energy in a calorimeter, if you just add, the raw signals and things like that, you still need information from calibrations and other databases to be able to reconstruct the energy of that particle. And so, so that's where you can basically kind of, as we say, cook the data. So you have this data production, and then you have your analysis. And I put validation on this slide. We'll come back to the validation in a little bit, but validation will provide basically benchmarks for what's coming out and be able to compare things that come out of both detector and data, basically data production. Okay, but we're all here in software, so we're going to talk about how this model sort of translates then into something when we talk about simulation. So in this case, instead of having your actual physics events, you might have like a Monte Carlo generator, right, which has some list of events that can get sampled in some way or weighted in some way. This passes into your detector simulation. So I kind of made the detector simulation one very big box. You could think of it as two things, right? Because you have your detector and you have your digitization. But in this case, I was kind of thinking that, it passes into your detector and out comes basically this digitized signal of some kind. And that's what goes into EIC recon. So then you would have you would work with EIC recon. You would run this on the data, and you could basically then have sort of your simulation production, which would basically cook this sort of data, and then you would have your final analysis that you can do on the other end. So if we talk about simulation from the beginning, we can talk about, we have the Monte Carlo generator, so you can input events from different kinds of generators. There's several available, particle guns, and you can have sort of optional physics backgrounds that you can put in. If you talk about detector simulation, you can talk about, you have your JANT4 simulations, which have your DD4 HEP kind of background to describe, like library to describe your geometry. Then you can output the data into this EIC data model. And then you can also have algorithms then that take the output of that data to transform these sort of JANT4 hits that they would give you if you ran just JANT4 by itself to mimic what you would see in the real detector. So really digitizing things in time to make some sort of signal that you might see in the electronics. And so this could include all sorts of background. Then you could have pile-up types of effects, inserting beam bunches, all sorts of things like that. So all of that then would go into EIC recon. So EIC recon's kind of special because at this point, it should be able to basically work on the data, to reconstruct the data, whether it's actual data or whether it's what's coming out of your simulated data. And so that's why that's another kind of goal of the software, right? Is that we can develop EIC recon so that it should be doing the exact same thing when we move to real physics data, or whether we're working with just simulated detectors. So this is our realistic reconstruction algorithms. So we run that, and we can also then process the data using all the calibration information that we would need, corrections, like I mentioned, like, for energy loss or things like that, everything that you would need when you go to cook the data to get out, what you should get when you get to your analysis, which might be, you'll have your particle ID, you'll say this was maybe an electron, this is, what kind of energy or momentum it had, where the interaction occurred, things like that. And that's where the users then can do analysis in plain C++ root, Python uproot, but this should all be pretty accessible then. So we also have validation, which we don't have a tutorial on today, but I wanted to include the link here. So there was a tutorial that was given in January for how you could develop your own benchmarks, but validation basically runs on these different productions so that you can also compare the output of detector and what you're getting out of the EIC recon to make sure that you're not getting, so that we have some way of benchmarking what's changing basically, and the quality of the data. Yeah, so here I just wanted to include some comments about some of the structures. So again, we try to work in a way that we use existing toolkits to support what we're trying to do. And so you have these HEP-MC3 kind of library that would be kind of how you can input basically any generator that you want, but you have to have a certain format. And then we have our Jana 2 framework, which we had a talk about yesterday. And so this is sort of where everything happens in terms of how since we'll be streaming things eventually. So this is sort of what helps us to simulate and read out basically with this data frames and things like that. And then also to do the multi-threaded processing. Okay, and then we have, right, so I just wanted, so this is just kind of more information on what I already said, basically. Yeah. Okay, so I wanted to mention that we would be working with different working groups, right? So if you're working with Monte Carlo generators, detector simulation, you might work then with the physics and detector simulation working groups. And if you're working with EIC recon, then you may be interacting with the reconstruction working groups. Again, we also have a production working group. So if you needed to ask for specific types of, conditions or runs or things like that during a production effort, then you could also reach out to production working group or work with them to have that. There's an analysis tools working group and a validation working group. So these are all different areas that, depending on what you're doing, what your task is, that you might be able to reach out to them or get involved in those areas. So I kind of mentioned this already, but we always want to have production ready software. And so we do that by having sort of this overall simulation campaign strategy that we have every month. So this basically achieves kind of a continuous deployment of the software that's always ready, basically. It's also, it gives kind of regular updates on everything that's changing. And so you always have something that you can work with. And so they talked a little bit, I think, about the tagged software releases yesterday. And so that would be important, right, when we start to develop things for the TDR, that you're aware of, that everybody's working from the same tag software release for whatever you're trying to do, and to make sure that you're aware of what's in that release. And so just some of the things I was going to mention. So everybody should be by now on Mattermost. If you're not, of course, we'll try to get back to that at the end of this. So I just put the link here. So there's this Firehose Mattermost channel. So this can give you more updates as there's the production campaigns. Then there's a few links in here for how to access some of the information on those campaigns. So where you would find the reconstructed output files, the simulation and output files. There's also an FAQ for accessing the files. And so I just wanted to include all of these links here kind of for completeness. We're not going to have a whole tutorial on this today, but it'll be, well, topics of this will be covered under some of the tutorials. So yeah, and then you can always kind of find out more information about the framework from the landing page, which I already directed you to. So you can see here that there's sort of this directory structure that we use, right? And so, so I wanted to just include this here for reference for anybody who's looking at a file. Okay, so if you're getting involved in the software, you might be just kind of either somebody asks you to make a plot, asks you to figure something out, you know, some sort of big question. And so we were trying to think of the types of questions that you might be asked, especially with the TDR. So your questions might broadly kind of fall into one of two categories, right? So you have sort of detector type questions at the stage or physics type questions. And if you're looking at detector type questions, it might have to do with geometry, either changing it or adding to it. It could be kind of an optimization of some sort of geometry. You could be working on the digitization to make something look more realistic based on, you know, some sort of bench test. You could be trying to calculate an efficiency for something in terms of the detector, or maybe even looking at the resolution. And then you can have physics kind of questions that you might want to answer. So somebody might be asking you about types of physics things that you might want to ask. And that might be like kinematics, or, you know, will the kinematics be within this acceptance? You have a certain phase space and you want to know how that, you know, how the interaction that you're interested in will, you know, will be able to be detected. And then you can also implement algorithms. And so, and there's all sorts of other types of questions, but these were sort of some of the broad ones. So we tried to break it up into use cases. Okay, so for kind of the average person who might sit down and need to do something, we have sort of just detector study, or you have something where you're implementing the detector. You can have physics study type cases, or cases where you're implementing the physics, or you could also be working on validation or have to change something within validation. So let's talk about detector study first. So I'll just go through each of the use cases. So here you might have a situation where you're either using the existing geometry as it is, or you'll be modifying the geometry or the digitization, right? And so, so in that case, you're kind of messing with, so in terms of our sort of simulation chain that we have, you're working with things way up in here. And so I wanted to point you to, we have previous tutorials. We'll have a tutorial today on geometry, on detector geometry. And, but there's some previous iterations of different types of tutorials that have some other information as well. You could be asked to implement a detector. And so in this way, you might need to implement a whole new geometry. Then you may need to add the digitization for that. And you may need to then modify something in the reconstruction to read out that detector. And so, so in this case, we've also had some previous tutorials on this. So here you have some using simulations, geometry, and then how to, you know, do things using DE4HEP. You may be asked to look at, you know, the physics type cases. So if we talk about a physics study, right, then you might use an existing generator. And if you're using the existing generator, then you maybe just need to reuse the simulation to do whatever it is you're doing. In that case, you might be just messing with the analysis piece, right? So sort of the end of this framework. You can also be implementing a whole new generator. And then in that case, that sort of restarts at the beginning of this chain, right? Everything kind of has to go through. So you may implement a new generator, and then you'll need to request, you know, new simulation being run, but you'll have to run all those events through the different detector, EIC recon, simulation production out to your analysis. Yeah, so I just I borrowed this slide actually because I thought this was useful just to remind people that for Monte Carlo event generators to be included in production, you know, they have to be in this HEP MC3 tree format, and that you know, we don't want to have duplicates, right? So this is so I just wanted to put this reminder in here, because if that's something that you're doing, this would be something that you may run into. But of course, you'll probably be interacting with that working group, so you should be aware then of what other people are trying to run in the production. So if you're implementing physics, in this case, implementing a physics analysis, then you might run a prototype on sort of like an existing reconstruction. And so if that's the case, then you already have all the reconstructed data, and then you're just changing something in the analysis. You could also be developing sort of an enhanced reconstruction. And so this may require you then to make modifications over an EIC recon before you run this simulation production and then out to your analysis. And so we also have some previous tutorials here I wanted to point to, talking about analysis. We'll have reconstruction algorithms will be one that will have a second iteration. So we had the first version of this tutorial in January, and we'll be having this one again later this afternoon. And then, yeah, and then we have previous tutorials. Like we have this Python analysis bootcamp on the analysis tutorial today that we'll be talking about working with simulation output, where Stephen's going to include basically examples both in Python to basically kind of add to what we did in January, which was just the C++. Okay, and then at the end of all this, again, we have validation. So here we compare the output of the physics and detector studies. So this is really important for us to make sure that we understand, you know, as we progress in our development, you know, what things are being changed and how they're affecting things, and that they're all documented, and then we know, you know, we can validate basically those models that we're using. So in terms of you know, requirements to make a sort of a collaborative type of environment, we need users. So everybody, you know, everybody here is in some way interacting with the software. That's why you're, you know, associated with this meeting, even if you're just interested. And so, so there's kind of some things that you'll need to get to be set up, basically, to be able to be collaborative with other people. So you'll need to follow the instructions on the landing page to get, you know, into the GitHub. There's also some tutorials that I tried to point to that would help people with GitHub that don't have a lot of experience. We also have Mattermost. So we use Mattermost sort of like this help desk. So anybody that has questions or issues can always write there. And there's a lot of experts around that'll be able to answer the question better than just if you send an email to somebody. This way, everybody can see the question and answer. So this is all what gives us basically this sustainable software effort, which is the goal of all of this. But I want to emphasize here that, you know, a lot of the way we work. So it's, you know, we give a lot of feedback to each other. So even in GitHub, right, there will be discussions, you know, on what it is that you're doing, you know, if there's a better way to do it, if, you know, and before, you know, as you make the pull request, there will be discussions and things like that back and forth. And so I urge people not to be intimidated by this process. It's a learning environment. So it's very, you know, it's overall all positive to make basically to keep and maintain this sort of sustainable software. And so, so I think it's, you know, it's a really good thing. And I think the more people that are involved, the better it gets at some point. So I pointed you to in the instructions, you know, for getting set up here to the landing page. So here I just took a recent screenshot of the landing page. And so we have, you know, a few, let's see, I don't know what screen I'm sharing. Yeah, this one. Okay, so we have, you know, 4 major kind of buttons that take you to the things that you might need. So if you're a brand new user, you would probably just go to this Get Started button. If you're interested in the tutorials, you can go to the tutorials. We have the HEP Software Training Center link. And so the reason I wanted to include that was because it has a lot of additional information for people who just need to get up to, you know, programming in sort of, you know, this Unix type of environment, or people that need to get familiar with GitHub, or, you know, basic kind of basic things to get you started that, you know, at some level, everybody needs to know, but you may not have had experience with it before, or have had all of the right information. And so if you click on the Get Started, for today's tutorials, you should have joined the GitHub. So that can all be done with the instructions here. You should have joined Mattermost. So again, if you're not on Mattermost, you know, at this moment, drop a message into the chat of this of this meeting if you want, and then somebody can send you, basically, if you drop your email in there, anybody can send you an invitation to join Mattermost. If you want to sign up for mailing lists, so there's the collaboration mailing list, which you should be on, as well as the software mailing list. And then when you join a project, so this might come back to, again, what the question is that you're trying to answer, so whatever your use case is, but you can look at the Epic Wiki to kind of see how, again, this structure that I tried to introduce at the beginning, with your physics working group, detector subsystems, and software working groups, to see maybe who you need to join. If you're trying to work on a specific detector subsystem, that might be a simple choice then as to who, joining a particular detector subsystem group and, starting to get active in participating in meetings and working with those individuals. Yeah, and then you can always go back to, from the landing page, you can also go into this HEP software foundation, which we sort of lean on because there's a lot of really good materials in here that have already been, a lot of people have already tried them. They've had live tutorials, and then this is basically all the data that they teach. So I encourage you to, and this is just a screenshot of basically the beginning of their site. So there's quite a lot of information here. So anything that you have a question about that might be kind of basic in some sense, or maybe not covered, you can try to check and see if it's something that you can learn here. So, and I would encourage everyone to check that out. Okay, and then the tutorials. So if you went to that tutorials link, you would see that we have several tutorials. So I've already posted kind of like a feedback link here on this month's tutorials. So definitely anybody that participates in the tutorials at all, I ask you to just submit anything, even if it was just to say that it was useful. Or if you want to give something more detailed, that would be great. So the more people that participate and give feedback, it gives us a better sense of what people need to see in the future, and what's, what could help you to better, get started with whatever it is you're trying to do. And so some of the tutorials in here, I pointed you to the setting up an environment. This is just to really get up your EIC shell. So everybody should be set up on EIC shell by the time we start the tutorials today. There's also other tutorials. So the next two listed here are the two that we'll be covering this morning, so next, and then early this afternoon. And then if you scroll down, you'll see the reconstruction algorithms tutorial there as well. So these are all posted. When they have videos, video recordings, they're linked there. So these might not be the most recent video recording, but they're at least the best version of the video recording that we have. And so we would hope that the ones from today, we would have new video, videos that we can upload with the tutorials. Okay. And then we have an FAQ, which is still sort of a work in progress, but it's a work in progress because it's a great place for everybody to get involved. And so, we solicited the working groups almost a year ago now, I guess it was last summer, for various types of things that they would want for tutorials or for just different types of questions that come up. We tried to kind of pick out the things that fit better into just sort of an FAQ rather than a tutorial, but just something to capture that knowledge. And so, but of course, the FAQ is only useful if people are using it, if people are contributing questions and answers. And so, there's an email link here that you can basically email with new questions. If you want to, get involved and make a better answer, something like that, we can help you to implement that here. So I would really encourage, the FAQ is only good enough if people are using it, basically. So, but we're hoping to capture anyway some of the questions that get continuously repeated when people are trying to get started. Okay, and then everybody should be also on the Mattermost channel for this tutorial. So this was sort of the screenshot a few days ago, setting up this Cern April 2024 tutorials. And so if you're in there, then you can ask questions, whether you're in the room or online. Yep, and there's already a link in the chat. So anybody in the chat, anybody in the Zoom can click on the link in the chat to just make sure that you're following that thread. So we did this back in January, and it was kind of a nice way actually of saving a lot of the questions that were coming up throughout the tutorials. You can even see that link a little further down. So, so join the Mattermost channel. We'll be monitoring it all day. We have people online and in the room that'll be assisting during the tutorials to make sure that people, as they get stuck, they can have their questions answered with the experts, and also, if there's something that starts to kind of arise for everybody, then we can sort of, address it for everybody. Okay, so I wanted to leave time here because I know that the instructions getting out to everybody here were somewhat later than I had hoped. And so I wanted to give time here at this point to basically see if everybody was able to get to EIC shell. And so if everybody has their GitHub, they're on the Mattermost channel and they have EIC shell, then they would be ready for the next tutorials. If you had any kind of problems with any of these tasks that were asked, then now's the time. We have experts online and in the room. So I don't know, I guess I can open the Mattermost and check, but is there anything on Mattermost? Nothing? Okay.
I think I have a generic question.
Mm-hmm. Yeah. Let me see if I can get one of these.
Hello.
Yes.
Hi, this is Ajay.
Hi.
So I still couldn't get EIC shape on my laptop, and so I tried. I'm confused whether I still need Singularity or not.
So it depends on which system you're running. You can use, you don't need Singularity. You could use Docker, depending on which system you're running. So you're running a Mac, right? So
Yes.
You should be able to just have Docker. And as long as Docker is running, then you should be able to just like open a terminal and run that, that first line command.
Right. So that command is running, but when I go for installation, it keeps complaining about Singularity not available in the path.
Interesting.
I confirm that if it fails, it just looks for, I can look to my PNL machine and do it there with Singularity.
Right.
Even I'm facing it.
Interesting.
On a Docker, on a Mac, you need Docker. In principle, it should be possible with Singularity, but it's not set up that way. So in practice, on a Linux machine, you need Singularity. On a Mac, you need Docker.
Yeah.
So, the instruction, there, it lands me to the page where it says, here. So it goes to this, either I should have Singularity or append tuner. And from there, for Mac, it says that, one can install a virtual machine, which is Lima. And from there, so there are three set of commands, basically after installing Lima with QEMU. This starts this append tuner, and so that is working. But from there, then I go to run that command, which is Singularity. This Singularity run Docker accessing Alpine, or
Okay,
one.
Would it be helpful to share your screen?
Yes,
So we could just see your screen. Okay, so let me. I think I have to stop sharing first. So, no. Okay, this is set up. Which one? I have a shared screen, but he should share.
Yeah, you have to stop. Oh.
It looks like I'm not sharing. It's set up differently. There's some sort of. Oh, this one. This middle button.
Display. Yeah.
Yep.
Stop the share and then I'll restart it.
Okay, it looks like it stopped sharing or something because now I have the video. Okay, yeah, so I think you should be able to share your screen now. We can see.
Yes.
Oh, it's side by side.
Okay, can you see my screen?
Yes. Mm-hmm. Yep.
Okay, so like from here,
You just start with the curl command. Ignore all the 1, 2, 3.
Yeah.
Just use that curl straight away. That one. Yes.
Okay.
And do you have Docker running right now?
If he doesn't, we'll
Yes.
see.
Yeah.
Okay. So. Okay. So I guess same.
Hmm.
Okay. So it complained about the Docker.
You have to start up Docker.
You just have to open it, basically. So you don't even have to do it from the command line. You can just open the app from like your applications.
Yeah. So I mean, I was having multiple versions of Docker, so I have removed that. So right now, so I mean, I don't need these things.
No.
No, just hit Option space. No, sorry, Command
Oh,
space.
sorry. Okay.
And search for Docker. Just start typing Docker. There you go, and open it.
Okay.
It'll probably take him. Yep, go for it.
There you go. Yeah, that's okay. This is what you need. So it's running now.
Okay, so try again with a /EIC shell.
Okay. Yeah, I think now it's fine. So
That's great.
This will take a few minutes.
Oh.
Oh, you have a good internet connection. It won't be too bad.
Yeah, so thank you. You've demonstrated this now for
Thank you.
everybody. So this is great. Okay.
I'll stop sharing.
Yeah, okay, sounds good. But I think you're on the right track now. Okay.
Sorry to interrupt. In mine, still it's not working. Can you please help me also?
Okay, so let's see. Did you post your question somewhere yet? This is Rohit?
Yeah, yeah.
Did I say your name right? Okay. Do you want to share your screen?
Yeah, I just
Okay.
Thank-
Which machine are you running? Okay.
are you able to see my screen?
Yes, we can see it.
Yes. I ran that curl command. So
Can you do a Control-C, please?
okay.
Try again with the /EIC shell.
Nope. There's a typo. Yeah, there you go.
You can just try the
Tab.
tab now.
It's opening a gate.
Singular.
I know exactly what this problem is. This is running Ubuntu, I'm guessing.
Yeah, base is Ubuntu. Yeah, I'm in Linux machine, but it's Ubuntu, yeah.
And you probably did something like apt install Singularity.
Yes.
Well, Singularity, idiotically enough, there's a game called Singularity, and Ubuntu installs Singularity the game instead of Singularity the application.
Oh.
I don't remember the name off the top of my head. You have to Google Ubuntu install Singularity container or something like that.
Okay.
It's like, yeah.
It won't get you the EIC shell.
Okay, I'll do that and I'll share my screen again. when it's-
Okay, yeah, definitely,
Perfect.
definitely let us know. We still have some time, so let us know how it goes.
And make a note that we need to add this.
Yeah, we should add this instruction. We'll do that. So that's an interesting problem.
If nobody has questions, can I ask?
Sure, go for it.
So, are there any plans on new tutorials? For example, I'm lacking a tutorial which can run the whole production chain with analysis using Condor system batch.
So that would be great. So yeah, I mean, we're open to suggestions. So this is sort of, we have our first batch here. So if you want a tutorial like that, we can.
Yeah, I've done it myself.
We will include some aspects.
I added something to the snippets from already doing it, not on Condor, but on the JLab system.
But many of us are a bit BNL, so.
That's the thing. I mean, at some point,
Maybe
we will. I think what we're going to do after this, after the tutorials are over, we're just going to add a Condor version of that. I can add a Condor version to yours.
Yeah, I know the version I uploaded for JLab, I think Woutward said basically don't abuse, running EUF and stuff like that. It's basically just a shell script,
Right.
which runs the SE shell, does some commands within it and stuff like that. Yeah.
Is there some?
I think, yeah, Collie, you have a version of it for Condor, right? So
Yeah, exactly.
Yeah, that would be very useful. Thanks.
I'll mention too, so all of the way we do the software tutorials, they're all GitHub controlled. If anybody wants to add something like certain lines, I mean, you can certainly do that. Just make the pull request. You can add in the comment that was missing or whatever. So
Should I
just
add
to
it
make them all better for
snippets,
the future.
or which place to write?
Well, you'll see. So
Okay.
I'm showing on
Good.
this screen here, this was the EIC tutorial for setting up your environment. Oh yeah, I'm not sure.
Or should I do the software carpentry project?
There's it's in the format, but it's ours. So these are all in our EIC, in our GitHub repository,
Yeah.
right? So this tutorial you can find there. So if there's something that like you think of
Okay,
that like, would be great to
Mhm.
add, you
Yeah,
can certainly
I know,
contact
okay.
the person
Thanks.
presenting it, but if, yeah.
So yeah, I think the problem with that it doesn't really naturally fit in any of the tutorials we have because each of them is quite specific. I was going to add this, but fought against it because it is more full chain rather than just the analysis. But we could definitely add it. There's an extras tab at the top of these. I was adding sort of extra information to that. So